we have f of xyz here equals to cosine xy plus a sine of z squared. So this is the problem that we have in front of us. And then we're still going toward the first partial derivative. Okay, so the first partial derivative, because we're going to talk about the second partial derivative as well, a little later. So now this is how we do it. So we said the first partial derivative with regard to x. So we're going to do it with regard to each of the variables that we have. So that means we're going to have to deal with x, with y, and then with z. Okay? So with x first. So now we have trigonometric functions here. So this is cosine xy. So we also have to know the derivative of cosine. Okay? So for those who forget about these concepts, please go back to our former videos where we dealt with derivatives. Okay? So this one, which is cosine, so we're going to have to direct ourselves here. So like we did before, we have to have a target. So which one is our target? Is x. So wherever we have x, that's what we have to go to. So we don't have x here, so that means sine z squared is going to be considered as a constant. So that would give us what? 0, because the derivative of a constant is 0. All right? So now this one is cosine, so we have to target this expression here. Okay, the term here, that's the one that we have to go, for. So now we have cosine. So what is then the derivative of cosine? It's negative sine. Okay? And once we go also inside the parentheses, we have xy. So we try to find the derivative of xy also with regard to x. So with regard to x, so that means we're going to treat the y also as a constant. So if we treat the y as a constant, so it's going to come out. Okay? So the y is going to come out. And then we just say that the derivative of a cosine is negative sine, right? So we have negative, then we have the sine, and then we keep the xy. Okay? So we're actually following the chain rules, of derivatives. So we have negative y sine xy. Okay? And again, for this one here, it becomes 0 because it is a constant, and then the derivative of a constant is going to be 0. All right? So let's go to the second one and see how we do with that. So we still finding the derivative, the partial derivative of this one here with regard to y. Okay? So now we still have to target the term with y. So that's what we got to do. So again, for the second term here, there's no y there, so we're going to consider that again as a constant. So the derivative of a constant is 0. So now we go to cosine xy. So cosine xy, we targeted this one now, and then we have y in there because we have y in there. Okay? So because we have y in there, the derivative of xy will give us what? X is going to come out because the x is going to be treated as a constant. Okay? So if x is treated as a constant, so we're going to have the x out. And then what's the derivative of cosine? Is negative sine again. So it's negative sine. And then we have xy back over there. All right? So this is what we have for the second one. For the third one, so that's with regard to z. So the partial derivative with regard to z. So that means again our target is z. So wherever we have z, that's what we go to. So that means cosine of xy now is going to be treated as a constant. And the constant of derivative of a constant again is 0. So this one will be 0. And then we have to find the derivative with regard to z over here. So now again we go inside the parentheses and find the derivative of z squared. What is the derivative of z squared? It's 2z, right? So it's 2z. And then, let's don't forget, because this is a composition of the sine function and then the z squared. So that means the derivative of sine is what? Is cosine. So it's 2z cosine. Then we have z squared back there. We see what's happening here, ladies and gentlemen? It's not difficult, but you have to take your time and then do it. So you take your time once at a time, and now once you know what you're doing, now you can run with it. Okay? So remember, some of the concept that we just talked about here is constant of the derivative, of a constant is 0. Okay? So that's a very important item that we need to know when we're treating these problems, that we're taking care of them. Okay?